You think back into the 50s and the 60s when telephones and electricity were introduced, that's where it started. For me, who grew up on a fifth-generation farm in the state of North Dakota, when that fiber optic got built to our farm, that changed everything. For the ability to do business, the ability to check markets, check weather, do what you needed to do on your farm, that changed the game.
Yeah, looking at the advancements that we've seen in agriculture, I remember riding in the tractor with my uncle, and it had a little indicator on the dash showing. It was one of the first iterations of GPS showing how to keep the line straight. And starting at that point, that's kind of where I remember the technology starting. Of course, before that, you had foam markers and different things to keep lines straight. But even from that point to now, of seeing a lot of the autonomous systems that are able to go out in the field and operate with very minimal human involvement. I mean, a lot of times we see operators bring the machine out, keeping them restocked, and they're following along on a tablet to monitor progress of the robot. So that's been really amazing to see that.
A lot of what precision agriculture is focused on is, maximizing the outcomes of farming and ranching. And part of that is minimizing the input costs through various means. And, technology is really playing a big role in that these days.
If it's a sugar beet farming or farm and ranch cattle producers, they all have different technologies that they need to deploy, and our fiber networks are supporting that.
We're getting very close to having all serviceable addresses in the state connected to fiber. So that's fiber to the premise, fiber to the farm, fiber to the home. With over 70,000 miles of fiber in the state, we've got the superhighway built to every premise in the state of North Dakota. And now what can you do with that? Ag is king in North Dakota, and with the things that NDSU is doing in the state and producing talent, with the intersection of technology, research, education, and the availability of a network like we have in the state, there are some really interesting things happening right now in the ag space.
We have faculty researchers here on campus. We call it the main station here. So it's the main research hub, if you will, but then we have 7 research extension centers across the state of North Dakota that is really focused on particular needs of that part of the state. Yeah, so we've been working with Dakota Carrier Network and T3 as partners on developing some technology infrastructure that's important to our precision ag research here. We've been working on identifying and implementing the networks that are needed, both fiber as well as wireless networks, to connect our research extension centers across the state to our main campus here. The data that we collect over time has a lot of value in improving the knowledge that we have, and that data then enables precision agriculture to be more finely tuned for the outcomes we're trying to achieve.
DCN's been a partner with Grand Farm since it was formed. This is their second, maybe third location where the Grand Farm is now, I say, permanently located. And they have a great facility that is an incubator. It brings in startups. It brings in people that have thought dialogue about how can we make farming and automation and precision ag better for the world.
Yeah, so as we think about the different communication protocols that are out here on the site, they're all purpose-built for different reasons. So first, having fiber out on the site with high-speed bandwidth has been huge for enabling different things like the work that happens in this facility here, uploads of drone imagery, different applications that need large amounts of data pushed up to the cloud for different processing. So that's been the foundation of all the other technologies. The private cell network has been beneficial of when we need, again, that high bandwidth connectivity throughout the campus. So we've used that with different tablets that are used to control drones or other robotics on the field. LoRaWAN, we see that a lot more with some of the smaller sensors that are deployed out throughout the campus here. And that could be things like soil moisture sensors, water level sensors. The understanding of, fiber as the backbone is so important, because even if it's cell networks, LoRaWAN, private cell, even satellite, it all relies on fiber backbones to transmit that data.
build the core once, and then figure out what comes at the edge from an application standpoint. Build a network once, build the connectivity to it once, build the fiber optics to it once, and make it agnostic so that the edge could be one of 10 different technologies from a wireless or a build-out standpoint, but it still rides that same fiber optics to be able to extend technology in the state.
I think we're right at the base of a big wave that's about to hit us. I think having AI at our fingertips now totally changes the game. I think we're going to see an acceleration of sensors. We're going to see an acceleration of analytics. I think we're going to see an acceleration of automation. And all of this is a great thing for farmers and ranchers who need this to try to produce more, to try to produce better quality, to try to reduce their losses. I think that's important. I think the AI is going to enable tremendous things over the next 5 years that we can't even envision right now.
I think that we have continued to move beyond, right? Beyond what we even thought was possible. Right now, in 10 years, what is the next thing? Where is the ag and the precision ag industry and automation going to go when you have the entire ecosystem built from a networking standpoint? You got very few places in the world that can say that they have that built. What is possible? I don't even know if I know the answer to that yet.